Hello and welcome to another edition of my presidential video series. For this month, I am really fortunate to be joined by Ken Ruffin. Ken is the president of the National Space Society of North Texas. And by way of background, we were both in Dallas, Texas last week to experience the total eclipse. We were both at the Frontiers of Flight Museum in Dallas, where Ken was a featured speaker, and I heard him speak about an hour or so before the eclipse began, and I was super impressed. And I invited him to join me for our video series for this month. So welcome, Ken.
No, thank you very much. It's a pleasure to have been invited, to this virtual interview. So thank you for this.
Yeah, and one of the things that happened at the eclipse, as you know, was that we had a little bit of a weather scare, in
Yeah.
that the forecasts were for 90% cloud cover according to some of the models.
Hmm.
Some were saying it wouldn't be so dire and that we would get some clear skies. Of course, for the eclipse, we want clear skies. We want to see the eclipse. We don't want to, we don't want to see it just getting dark. We want to see that magical ring of the sun
Hmm.
around the moon. That's what we're there for.
Yes.
So luckily, there were different models, weather models, and we were talking earlier. I was talking to you about how there's a lot of different models. I think of them in a lot of ways as similar to actuarial science, where we have models as well, where we model and predict the future and try to make decisions today based on that. One of the things personally for me that came out of that was I was looking at the weather and getting a little bit worried that we were going to have overcast skies, according to some of the models. And the decision I almost made, fortunately, I did not do this, was to fly back to New Jersey
Mm.
on Sunday before Monday when the eclipse occurred, and then drive up to Vermont, where unusually they were having clear skies predicted, even though normally they were the ones who were supposed to have the cloudy skies, in Texas was supposed to have the clear skies. But I looked at some Canadian models that said, no, it's going to be clear skies. It'll be fine. So I used my actuarial wisdom to make the right decision and to stay in Dallas, Texas, where we had a spectacular eclipse. It was so majestic and beautiful. And I was really happy to experience that with you and to use some of my actuarial skills to make the right decision in this case.
Yeah.
Yeah.
Yeah, that was the totality, the total solar eclipse. It was one of those moments that once you experience it, you'll remember it for the rest of your life. And, I had heard things like that before from people who had witnessed it. And, I'll confess, I was a little skeptical. I was like, it can't really be that exciting. It's the sun, it's the moon, what's the big deal? Uh, it is a big deal. Once you
Yeah.
experience it, yes, you absolutely understand.
Yeah.
So yeah, I'm glad that I had a chance to experience that as well.
Yeah. And you'll see I'm wearing the t-shirt from the eclipse. And
Hmm.
it looks better than this. The actual
Yeah.
eclipse is even better than this. And this looks pretty cool, I think.
Hmm.
I was fortunate enough to see the one in 2017. I went to South Carolina to see that one. And that's why I was hooked and said, I must see this one again. And
Hmm.
now I'm going to start looking where I could travel outside the US to get another one before, the next time it doesn't come to the continental US until I think 2044.
Hmm.
Yeah, so
Hmm.
that's a long
Yep.
way off. So
Right.
I don't think I want to see this again. It's also an amazing experience that it's kind of it's even though it's very scientific, right? We could predict as opposed to the weather. We were able to predict this, and hundreds of years
Hmm.
ago, we already had the science and the math to calculate when this was going to be, where this was going to be, what was going to happen,
Hmm.
and so in a way, it's like you said, it's expected. It's the sun and the moon; they're coming together. So what?
Yeah.
But when you
Right.
see it, it's beyond this. It's an emotional experience. People
Absolutely.
trembling, people start crying. I mean, it kind of
Hmm.
hits you somewhere where it's the science is amazing, but it's even
Hmm.
more amazing the experience.
Yes.
And also that
Absolutely.
the other thing that really blows my mind is that you know that someone a long time ago figured this all out, and they were right.
Hmm.
They said this is what's going to happen now, and that's exactly what happened. Now,
Yes.
which is
Right.
just incredible. That in itself, just the incredible, the intellect and the human capacity to figure this out and understand our universe is amazing. And I know
It
that some
is.
of what you do in your with your organization, where you do look at space exploration and the future of space, and again, similar to what we as actuaries do, where we're looking at the future as well, and
Hmm.
doing things about it today. You also are looking at where we're heading in the future, and you're taking action now as far as you have to set up. These are long-term missions, a lot of them. You have to do something now to get somewhere in 10 years from now. You can't just have a spaceship,
Hmm.
far out by just snapping your fingers. We're not yet at that. We don't have warp speed like on Star Trek yet. So
Unfortunately.
yeah. So I don't know if you want. Could you talk a little bit about what interests you and what you're doing in that area?
Oh, absolutely. So, as the president of National Space Society, I've been either vice president, I'm sorry, National Space Society of North Texas, not the entire organization, just locally. So, I've been either vice president or president since 2011. And the primary thing that our organization does, locally and nationally, is to educate the public, to inform the public about, excuse me, excuse me, to
Right.
inform the public about the latest information in space travel and the plans for the future of space travel. Most people aren't aware. The local news stations and national news networks, cable news networks, they don't typically talk about space on a regular basis, and when they do, it's not at all treated the way that it used to be. From what I've seen in videos back in the 1960s, I can't say that I remember any live uh, news coverage from the 60s, except the Apollo 11 moon landing, the very first moon landing. I was only 3 years old. My parents woke me up to see Neil Armstrong walk down the ladder on the lunar lander
Wow.
and be the first person on the moon. But I was sleepy. I was 3 years old. Of course, it was 1969, so it was a black and white picture. And I was thinking, it looks better in my cartoons, it being the moon. So I walked out the room, got back in the bed, I was not the least bit impressed. And fast forward till I was 8 years old, it's like, wait a minute, that was awesome. I actually saw history being made, even though I was too young to appreciate it. It came up in conversation with my parents, and it's like, yeah, I'm glad that I had a chance to witness that, even though it took me 5 years to to recognize and appreciate it. So anyway, back to National Space Society. Again, informing the public. There's so many different ongoing NASA missions that, again, rarely, if ever, get any TV news coverage. TV, I, I can't say internet news coverage is lacking, but it all depends on where you look. You know, if you're like me, if you go to the websites, if you go to the apps that are dedicated to talking about NASA and the commercial spaceflight companies building their own rockets, I see that information literally on a daily basis. But unless that's what you're looking for, you're probably not going to see it. So I see it, I summarize it, um, put some relatively technical information. I try to explain it in plain English, just in layperson terms, without technical jargon. Or if I have to use technical jargon, I paraphrase. Here's what that means. In plain English. And the hope is not only that people will be informed, but maybe even become more interested in space travel than they ever thought they would. And if it's not them, maybe when they go back and talk to family, friends, um, colleagues, whatever the case may be, maybe some of those people might be interested. And I have gotten, I would say, referrals due to due to someone seeing the presentation. They weren't necessarily interested, but they knew that so and so probably would have been. So yeah, that has worked out as well.
Yeah. Yeah, and listening to the presentation you gave, which was amazing. It was, I mean, I think it was an hour long. It felt like
Hmm.
it was minutes. And then all of a sudden we realized, well, we have to go outside because the beginning of the eclipse, the partial part is going to start soon.
Right.
Because just like kind of just flew by. And one of the things you were talking about was also traveling of a lot of exploration with the sun, which is kind of
Mhm.
interesting because we typically think of, well, we can't get so close to that because of the heat and all that. I was reminded as you were speaking, I thought of immediately. I almost laughed out loud in the audience because I started thinking of the show Ali G Show, which was an HBO show from a while ago, where he's interviewing Buzz Aldrin. He it was Sacha Baron Cohen. He impersonates this character who's kind of, supposed to educate the public about things, but he's not very intelligent as the character.
Mm.
So he asks like sometimes silly questions. But Buzz Aldrin was, one of the astronauts who was in,
Mhm.
went to
Apollo program.
walked on the moon, right?
Yep. Second guy.
So the second
Hmm.
person, right? So he asked. First of all,
Hmm.
he says, first of all, he's calling him Buzz Lightyear, which is hilarious, and
Oh.
and and he's just going along with it. He says, were you like upset that Louis Armstrong got to walk on the moon before you, which in itself was hilarious. He's
Hmm.
messing up all the names. But then he says, when will man walk on the sun?
Oh no.
And he goes, never. He goes, well, why not? He goes, because it's too hot.
Yeah.
To which Ali G says, oh, what about in the winter?
Oh no.
which is
Oh,
just
that's
which is and this,
hilarious.
I don't know if he knew ahead like what the interview was, but he was great because he just went along and educated. He actually did serve the purpose of through some humor, but really explaining a lot about the
Hmm.
sun. So I was thinking a lot when you were talking about the sun, about obviously the heat of the sun, and I
Hmm.
was kind of intrigued, and maybe you could talk about a little bit about how what we're doing as far as you know uh, studying the sun.
Sure, sure. Whether it's NASA probes independently or joint missions with NASA and the European Space Agency, also known as ESA, there are several heliophysics probes. Helios, as in that's the Latin term for the sun. So sun physics or solar physics. There are several probes which have been studying the sun for decades. So we've been getting information directly and indirectly about whether it's the sun itself, whether it's the radiation coming from the sun, space weather that I'm thinking most people are probably not familiar with. But there are times where the solar activity, like people will say solar flares, but the actual term is coronal mass ejections. When the sun becomes more active, it's like on an 11-year cycle, and we're kind of approaching the maximum activity now here in 2024, maximum of that 11 years. So there may be times that if people are using it could be anything from like ham radio operators to it could be like satellite TV and radios. I'm sorry, satellite TV and satellite radio signals. There could be interference
Yes.
from the activity from the sun. Also, worst case, the activity could be so bad that it could affect power grids here on the Earth, and that's something I forgot to mention during the presentation. But that's a worst case scenario. It's possible that a power grid could be overloaded
Yeah.
from the electromagnetic energy. But fortunately, because of these heliophysics probes, if if the intensity, of what's coming from the sun towards the earth is so extreme that it's likely to damage the grid, then power companies would be alerted uh, by NASA basically, and they'd shut the power grid down. So people would go without electricity temporarily and on purpose, as opposed to if the power grid wasn't shut down in advance and the coronal mass ejection damaged the power grid, the power could be out for months, as opposed to maybe hours. So lesser of two
Yeah.
evils. I'd rather be without electricity for a couple of hours than a
Yes.
couple of months. And
Yeah.
I would
We
imagine the
we have
listeners feel the
batteries.
same way.
Use batteries. Um,
Yeah,
yeah.
a
So
lot of batteries.
do we have a lot? Do we have ways of? I mean, how good is the forecasting, or how far out is the forecasting, or it's only very short term for
I
knowing
I
that?
I don't know exactly. I know that I'm fairly confident that we would have enough. Well, the power companies, the electric utilities, they would have enough notice. Whether it's days, hours, that I'm honestly not sure
Yeah.
of. But as long as it's enough to save the power grid, I'm
Yeah.
comfortable with that.
Yeah, and that's a
So,
case of, I mean, some people say, why are we doing all this exploration? What's the purpose? What's the benefit? I mean, there's tons of benefits. I mean, that's just
oh
one
yeah.
example of where you could have, you could take preventive action. There's also so many things we discover just in building the technology
Hmm.
for space travel. There's a lot of benefits that we as a society, I think I think this is true. I'm not sure that titanium, the way we were able to manipulate titanium and work with titanium, came from building one of the space shuttles, and now it's like in our glasses. And I don't know if that's, I don't know if that, I'm not a scientist to know if that's actually true, but I'd like to say, oh, these the glasses, they came from the space shuttle.
I have to confess, I'm not sure if that's true or not.
Yeah,
That it might be, it might not. I'll have to
yeah.
confess, I'm
I,
not
I
aware.
kind of should look it up, but I kind of like the story, so maybe it's better if I'll wait till someone proves me wrong.
Yeah, it's definitely a cool story.
Yeah,
So,
yeah. Another thing which I was thinking about just earlier today was about future eclipses, and I know that there's
mhm,
one that's going to be in a couple years in northern Alaska, quite north
mhm,
in Alaska,
yeah,
where and then and I'm not I'm assuming because it's so north in Alaska that that might be a place where you could see the northern lights.
yeah,
So,
possibly.
which is again a sun phenomenon. That's something from
Hmm.
the sun. I think a lot of people, when they see the pictures of it, which are phenomenal, they think it's something far out in space. But that's really
Hmm.
something that's very close to home.
Oh yeah,
That would be
in
kind of
our
cool to see an
atmosphere.
eclipse, and at the same time during the day you see an eclipse, a total eclipse, and then at night, at night you can see the northern lights. That would be
Yeah,
some
the
trip.
aurora. Yeah, the aurora borealis. That would be
Yeah,
a fantastic 2-for-1 trip. So
yeah.
yeah, that's something to consider.
Yeah, and I think that is that from the those lights are from those are the sun's lights, right? Being that you're
Yeah,
seeing
it's
in the atmosphere.
it's radiation from the sun, and the radiation from the sun goes in every direction from the sun. And there are times again when the solar activity, the energy the energy being released, I guess, from the sun. There are moments where there are these flares, coronal mass ejections, that aren't necessarily coming towards the Earth, but there's just more energy being released in general, more electromagnetic energy. And the Earth has a magnetic field, which protects the Earth for the most part from most of that electromagnetic energy, from most of the ultraviolet rays. Everybody's familiar with UV rays, sunburn. Well, thanks to our magnetic field, even though people still get sunburned, it's not nearly as bad as it would be if we didn't have a magnetic field. So
Yeah.
that protects us from most of it. Now, with high solar activity, those photons, those light particles coming from the sun, as they approach the Earth, there are bands of magnetic, they're invisible, but they can be measured by spacecraft. So there are bands that basically come, imagine like out of the North Pole in every direction and up and around the Earth and down to the South Pole. So like magnetic field lines. And in times of high solar activity, the energy from the sun, those photons from the sun, radiation from the sun, gets directed along those magnetic field lines towards the poles. And that interaction, that energy from the sun plus the Earth's magnetic field, results in the northern lights and the southern lights, or the aurora borealis in the north and aurora, I believe it's pronounced australis in the south.
Ah. Mhm. Yeah, that's and I know I guess maybe because of where I don't know which one. I guess it might be easier to see the northern lights, or maybe we're just closer that people tend to talk about going to see the northern lights. And there's more
Mm-hmm.
land, I guess, where you could go to maybe Iceland or places like that. You probably have to go to Antarctica. Is probably a little bit of a more
I was
difficult
going to
journey
say
to get
there's
there. So
there's actually more land at the South Pole because of Antarctica.
yes, yeah,
So
there's a lot. I mean, Antarctica, I guess, because we look at it in the globe, I think people don't realize how big the continent is.
yeah, it's
Because you can see
enormous.
it's on the bottom. You're not really looking at it when you're looking at one of those, globes that you might have in your home, or even in the maps that are drawn, where
Hmm.
they, where it's 2D, it's kind of on the bottom, and because of the way they stretch out the maps,
Right.
and
Yep. It's
it really gets a
spread
significant
across the bottom.
center. Yeah,
Hmm.
so so I think people don't realize that it's a pretty big landmass, but really cold and hard to get to.
Yes, exactly. And we're again
Yeah.
much closer, being in the northern hemisphere, we're closer to the North Pole. So
Yes.
I would imagine, for people who live in South America,
Mhm.
Australia, Africa, they probably talk as much about the southern lights as we talk about
Ah,
the northern. That would be my
yes.
guess.
Yes. And I believe I think there is another a total eclipse that will go through Sydney, Australia. I
Hmm.
think in a couple of years, maybe somewhere, not so far out. I think through New Zealand as well.
Okay.
So for people who really can afford to the time and the money to travel there,
Hmm.
that's probably a great trip.
Yeah.
Aside from the eclipse, but that probably kind of might be like a good bonus or
Yeah.
good timing to go there at that time.
Yeah.
Um,
Absolutely.
yeah. So thank you very much. This has been, really interesting, exciting. I'm really excited for some of our actuarial members to
Hmm.
hear from you. It's a little bit different than what we normally do. Um,
Hmm.
People already know that I'm like a giant space nerd buff. I just love this type of stuff.
Me
This
too.
is yeah. On
Mhm.
recent, there was a CCA interview series where I was interviewed by Michael Clark, who is a past president of our organization, and he asked me, "What would you do if you're not an actuary?" And I was basically telling him I would, be an astronomer
Mhm.
and study space.
Mhm.
So I'm kind of feeling good that I'm able to do that a little bit as a hobby,
Yeah.
and be able to talk to you. I really feel fortunate to have met you and to be able to have this conversation, and hopefully I might sign up for one of your events and
Yeah.
attend one of your conferences. Would be terrific.
Oh, yeah, that
Yeah.
would be fantastic. National Space Society on a national level does put on an annual conference, and I made references to conferences during my presentation. So in 2024, Memorial Day weekend, 2024, it will be in Los Angeles, the 42nd annual International Space Development Conference. So really short notice for that. But in May of 2025, it will be in Orlando, Florida, and the goal is before the actual 4 days of the conference itself, the Thursday through Sunday, on the day before, that Wednesday, that is expected to be the tour day. And that tour will include a VIP tour of Kennedy Space Center, which is about an hour and 20 minutes east of Orlando. So
Oh,
NASA's
nice.
Kennedy
Yeah.
Space Center.
Yeah,
So,
I was supposed to go there for I was at a meeting in Orlando where it seemed lucky at the time that there was going to be one of the launches, space launches
mhm,
from SpaceX. This
yeah,
is I think a year, not this February, not this February, but the February before. I guess February 2023. And I had tickets to go. It was like
right,
at 2 a.m. or something. It launched. You have to get there like at midnight, but
yeah,
that afternoon they postponed it, which is
yeah.
very common. I think they postpone
It
it,
is. It is.
again based on forecasts for weather and things like that. That we don't. Again, it's amazing that we know when the eclipse was going to be to the exact second.
Hmm.
Here, so
Years in
far in advance,
advance.
and yet we can't
Hmm.
tell the weather 5 minutes out.
You're right. It is amazing. I mean, the next total solar eclipse that will be here in the Dallas, Texas area will be in about 380 years. So,
Wow.
yeah.
Yeah.
And so, no, we won't be around to see that. But like you said, what's the weather going to be tomorrow this time?
Right.
We can't
Right.
say exactly. We can say what the forecast is, but it's not 100% accurate.
Right. And as
So, yeah.
actuaries, we love uncertainty and working with that. That is our entire profession is dealing with those uncertainties. If everything was the eclipse, we would be out of business. We wouldn't we wouldn't have anything to do. So I
Gotcha.
kind of appreciate the weather to some extent.
Yeah.
Um, yeah, to some
There
extent,
is a
there's similarities to the weather. People get a lot of slack for, everyone makes the jokes. The weather, they're the only profession who can be wrong all the time. Well, we as
yeah.
actuaries, we might be the same way, except no, since our projections are so far out in the future and so complicated, just no one
Hmm.
knows whether
Yeah.
we're hitting the mark or not until it's too late. So, but we make
Okay.
adjustments, of course, as we go along to best estimate what things will be. So we do have
Hmm.
a lot of we do correct as we go and look at
Hmm.
experience. We do experience studies and things like that. So we kind of do hit the mark in the long term overall, not for any
Mhm.
particular event, but overall where we average out to be correct.
Gotcha.
Yeah.
That makes sense. And speaking of like making the corrections as you go along, there is a tie-in with space travel. Um, in particular, when it comes to rocket testing. I mean, there are probably many, many other examples, but the one I would say, relatively familiar with is with testing a new rocket. So, and I'm not going to use NASA as an example. Their approach to testing is different. With NASA, they when they conduct their tests, their goal is 100% success with the very first test because they've done so much modeling and calculations and testing in advance, so that when they actually launch the rocket, um, which is really for in their best interest because NASA's budget comes from taxpayer dollars. When if a NASA rocket blows up, it's mentioned just ad infinitum. People still talk about explosions from whether it's the 2003, from the 80s. I've spoken to people who talk about rockets exploding back in the 60s like it happened yesterday. So when it's taxpayer dollars, yeah, it's kind of in their best interest to get it right. But in private industry, SpaceX, their approach is yes, they do their calculations, they do their modeling, and they take the approach of okay, we're at the point where where we can't really get any more valid data that they can be really comfortable with without actually testing, without actually launching the rocket and comparing what happens with the rocket to what's predicted in the model. And as there are differences, especially early on in the testing phase, they make corrections to the model, they make up improvements to the model, and they launch again, make more improvements to the model, so on and so forth, and then eventually they result in a rocket that's I don't want to jinx it, but I'll just
Yeah.
say really high success rate. And it looks kind of unusual if it's like if you don't know the method to the madness, it's like, well, when the Falcon 9 rockets were new, this was back in the early 2010s. They blew up a few rockets, and many people, whether or not they were space advocates like me, were very skeptical of the company. It's like they're blowing up rockets right and left. Um, but it was intentional because every time they blew a rocket up, they pushed the limits of like the pressure, the chamber pressure within the rocket engines, and they pushed the limits of getting the propellants, the fuel and the oxidizer, as cold as possible so they would be as dense as possible. So even though those were liquids, they would chill those liquids almost to the point of them freezing, going from liquid to gas. Because again, the colder they are, the more dense they are, so the more liquid oxygen they can get as an oxidizer, and the more whatever their fuel is, whether it's kerosene, whether it's methane, whether it's hydrogen, um, just really taking things to the edge. And in doing that, there was one rocket that blew up on a launch pad because a valve froze with that liquid just being so cold. And it couldn't flow, pressure built up, kaboom. So that happened early on. And, again, knock on wood, um, nothing like that has happened in several years now and hopefully never will. So that was the
Yeah.
Falcon 9 rocket, which has been their workhorse. They're planning in calendar year 2024, they're planning to launch that rocket about 150 times. So it's about an average of 3 launches per week, which is, I could not have imagined anything like that even 10 years ago, 5 years ago would have been a stretch. And now it's like, yeah, are they going to hit 150 or are they going to be at 140 something? That's kind of,
Yeah.
the
Wow.
situation there. And then their next, uh, I'm going to say the most, the rocket that they're still in the testing phase of now, which is the SpaceX Super Heavy Starship, that instead of just going to low Earth orbit carrying perhaps 20 tons, which is kind of the norm with the Falcon 9 rocket, the one that's launching about 3 times a week, the SpaceX Super Heavy Starship is intended to carry eventually 100 people at a time, whether it's to low Earth orbit and back, or if the goal is to go beyond low Earth orbit, for example, to go to the moon and back or to Mars and back, the plan is get to low Earth orbit, which would use up pretty much all the fuel, but then refuel the rocket
Yeah.
in low Earth orbit to go to the moon and back, and or refuel to go to Mars and back.
Yeah, a lot
So,
of it's weight prop. Like, right, if you have all the fuel in advance,
mhm.
and you need oxygen too, obviously, for people to
Oh yeah.
breathe, that you're using a lot of you're taking up a lot of space and weight. So
Hmm.
the refueling is probably key to making it work.
It
Yeah,
absolutely is. Their particular plan, the way they have it set up, it would not work at all without refueling. I mean,
yeah,
it's not even optional. Just the way that it's designed, because without refueling, it's just going to come back to Earth. Period. That's the
right.
only other option.
Yeah,
So, and with Mars, and this is something I didn't mention in my presentation, so you're gonna get the benefit of hearing me say it now. With Mars, now I mentioned refueling to get to the moon and back. Well, the moon, that's like a 3 to 4 day trip one way. You
yes,
know, there 3 to 4 days back. With Mars, it's about perhaps 8 months, maybe shorter, according to SpaceX, but they haven't explained how they can cut time off of that trip. So I'm waiting to see the details about that. But worst case, 8 months to get there. So it would be impossible for the rocket, for the Starship, to have enough fuel to get all the way to Mars and allow people to stay on Mars for X number of weeks, months, however long it might be, and then for the fuel and oxidizer to still be liquid for the journey coming back to Earth.
right.
Liquids tend to boil and evaporate. It's both, but the main thing is evaporation. They would lose liquid over a period of months and months and months. So the SpaceX plan is to have super heavy starships before any people go to Mars. They would send equipment to Mars first to literally process the fuel to create fuel using the carbon dioxide atmosphere of Mars, CO2, and liquid water underground in the northern hemisphere of Mars, H2O. So excuse me, using carbon dioxide and water chemical reaction to create CH4, which is methane. Like think of natural gas is like 95+% methane, um, and oxygen. The oxidizer for coming back. So those would be automatically created um, at perhaps 2 years in advance before people arrive on Mars. So by the time people get there, there'll be these giant fuel tanks ready to refuel the Starship for coming back to Earth.
Yeah, it's a lot of planning, and especially when you're
Hmm.
dealing with actual people going up, it's that there you don't have the luxury of blowing things up or or
No.
trying to see what might work or might not work. That's great for
Hmm.
for figuring it out and for
Hmm.
doing research. A lot of this is like an amazing operations research, problem of what's the best way to get there and figure it
Hmm.
out, and whether I guess you have the different approaches that SpaceX is taking, where they're willing to push things and do like these catastrophic type of testing, to
Hmm.
see what would happen, and they have the money and and maybe it's and the funds, and maybe they don't have the negative publicity to deal with,
Right.
like with taxpayer dollars,
Right.
so they could do that, and that might be maybe in the long term it probably is maybe the most it maybe has the best chances for success. It also might be the most economical if you have
Hmm.
if you afford to put the money in. It
Right.
might at the end of time, at the end of the day, they
Hmm.
might be getting a lot more bang for their buck.
Yeah, and that's
Yeah,
the general perception within the industry, that it is more efficient and more cost effective
yeah,
to test that way. But again, when you're using taxpayer dollars,
yeah,
you don't want people complaining about it 50 years later if your taxpayer
yeah,
dollars led to a rocket exploding that you paid for.
yes, yes.
Even if you only put in like $2 worth, still.
Yeah, yeah. Well, listen, I could talk to you for hours and hours about this. I love this. I'm so happy you were able to join me. I will put I'll add a link to your organization somewhere in the notes to this or in our newsletter so that people who are interested to find out more can do so and reach out and get more information and maybe participate in some of your activities. So
Right.
thank you very much for joining me.
Hey, my
And
pleasure.
yeah, and to our attendees and audience members, thank you for listening, and I look forward to seeing you next month for another video series.
Okay. Take care.
All right.